Hi, in this video I'm going to discuss about the model risk management. As the name suggests, model risk management is about understanding the risk involved in a statistical model. So when you build model and implement it in production, there are always risks involved with the model itself. The model is normally used to mitigate different kinds of risk, but the model itself has some risk. So this particular topic is very much very much discussed about in the financial service industry uh, or the insurance industry, which deals with a number of types of different types of risk models. Okay, so we will discuss the model risk management in the context of risk management practices in banking and financial service industry, and also the insurance industry. Okay, so quantitative analysis is is known in different names. Sometimes people call it quantitative modeling. Some people call it quantitative research and all. So quantitative analysis in the banking and financial service industry is nothing but using maths or statistics or quantitative finance in developing models for different kinds of decision making processes within the bank. So what are the financial decisions that are normally made by using statistical models or mathematical models? So a number of decisions are in fact taken using quantitative analysis. Okay, so by saying quantitative analysis, we will mean quant models, okay, or stats or math models, right? So people use it for underwriting credit, for valuation of exposure and instrument like option, future, and all. Managing assets. For that also, people use quantitative analysis, capital allocation, and liquidity allocation, and then capital or reserve adequacy. So this is for regulatory purpose. Okay, so for a variety of financial decision, banks and insurance companies use quantitative analysis. They use quantitative analysis using a number of theoretical areas or number of academic domains, which include economics, finance, statistics, computer science, applied mathematics, and so on. So quantitative models are all are very useful for a number of decision making process, and particularly useful for risk management. Okay, as you would know if you know the basics of financial service industry, a number of risks are associated with managing money. Whether it's providing loan to people, whether engaging with different clients, where there is always a risk of default. Client might not pay back the loan or pay back the or honor the agreement that has, or the contract that is there between the bank and the counterparty. So there is always risk involved, and for that quant models are used to mitigate that or to reduce that kind of a risk. But there is a cost involved. So cost which is involved in quantitative analysis is time, resource, and money, which is of course is a cost involved in almost everything that a bank does. But apart from that, there is an important cost that the bank might pay, and I use this word might because it may not be the cost all the times, but sometimes there could be a huge cost if there is adverse if there is the model that is built, or the quant model which is being used in the bank is erroneous. Okay, so there is adverse consequences of using a wrong model. So if the bank is using a wrong model, it is going to cost the bank a lot. Okay, and that is optional cost, right? Optional cost, why? Because if it is using a proper model, a right model, then there is no cost in terms of um, in terms of using a quant model. Hence, what is important to learn, and in this particular session and in the subsequent session, we'll learn about the model risk. That means the risk involved with model itself. Now, if you are familiar with the financial service industry risk practices, you might have come across credit risk, market risk, operational risk, country risk, and so on. But model risk deals with what is the risk involved in using a mathematical model or statistical model. So the model itself has some risk that is known as the model risk, and in this particular session we'll learn how to ensure that this particular risk or model risk is mitigated and it is well captured. Let me also tell you that whatever we'll be learning, although it is based on or it primarily focused on banking and financial service industry, it all these points can be well considered in other industries like supply chain or in retail or even telecom industry. So it can well be replicated with appropriate changes according to the domain that we are considering. All right. So model risk, when we talk about models could be financial model, economic model, statistical model, maths model, computational models. So model risk is involved in all kinds of model, and special emphasis has to be given to this particular risk because one can actually incur a lot of loss if a wrong model is used. So we'll see the details of model risk. So before that, let's try to learn what the components of modeling. And you might have, you might be familiar with the different components of modeling, but just to do a quick recap, we'll just learn a bit of it. Alright, so there are three components basically. One is information input, which is the data, and ensure that it is good. Process, that means you are building a model using different kinds of algorithms and finding out the estimates. The third one is reporting. Using the estimates, you create reports which can be used by the businesses for different kinds of decision making. Now, problem can come from all three sources. Okay, when we're talking about model risk, we're talking about error in the model. Okay, so we're basically talking about the error in the model, and it can come from either of these three sources: from data, from estimation, and from reporting. So we'll see what are errors that one can come across, or one will encounter, or one might encounter while building model and implementing model and using model in BFS industry. Model quality, normally people use a lot of matrices to be able to judge whether the model is good or not. One is precision, second one is accuracy, discriminatory power, and robustness. Okay, just to talk, I'm sure you would have learned most of the things if you're familiar with the predictive modeling. So precision is something that is very useful when you're building forecasting models. It has to be accurate enough. Accuracy is mostly when we are finding out whether the particular whether it's regression or whether a classification, whether it's correctly classified or not. So that's accuracy. It's like one is classified as one or something else. So that's accuracy. Discriminatory power. Okay, discriminatory power is something that is something is to do with classification, wherein we're trying to find the probability of finding something, or probability of a particular observation falling into some criteria. Okay, so the model is able to categorize or discriminate between two types of multiple types. Okay, one popular use of this particular model is like using the probability of default model, where you are trying to find out whether a particular customer is going to be a default customer, or is going to be a bad customer, or is going to be a good customer. So that's discriminative power. And the robustness deals with how long will this model work. Will this model be good for a long time, because there is going to be a change in data, right? Will this work for new data? Will this work for for a very long time, because the model should be robust enough to changes in the data. Sometimes some models are not robust. They are good with the current data, may not be good with data 6 months from now, and that is bad. So these are some of these some of the matrices, or some of the numbers which are used to assess model quality, and we'll see in detail. Alright, so what is model risk? So we define model risk as incorrect use of models. Okay, so it's as simple as that. Incorrect use of models. Okay, and what are the sources of model risk? Where will you encounter such cases where, well, there could be wrong model choice, right? So in the case of let's say you are building a model and you are using a regression model where you should have used a classification model. So that could be one example of choosing a wrong model, okay, or a wrong algorithm. Okay. Quality issue with the data. So data quality issue, if you are providing wrong input data, you're always going to get a wrong output. So that is important. Lack of subject matter expertise. So the model developer doesn't know the modeling techniques well, and he's using in a wrong way, and he's not considering the benchmarks which are being already provided by the other modelers or the industry experts. In that case also you will face issue. Human error. Sometimes everything is good, but some issue in coding, while writing programs, that could be an issue. Software issue. Sometimes softwares do not give a proper result, and it could be an issue with the softwares. Bad documentation practices, and that is probably one of the highest or the most probable reason for finding issues, because many times developers develop good models, but they do not document properly, and at a later point of time this becomes an issue. Wrong implementation. Okay, people who implement models are normally from IT, who don't understand models well many times, and there is always a gap. So that coordination has to be there with the IT team and with the modeling team, so that there is no issue while implementing. Lack of good governance. Okay, every organization should have a proper governance for models, and that is very important. So these are some of the cases where you will come across model risk, which is nothing but incorrect use of models. That means a model is either used improperly, or the model itself is theoretically wrong. Alright, if there is a risk, it has to be mitigated, right? So model risk can also be mitigated. How can it be mitigated? Robust model development practices. Okay, so there has to be a proper or a well-developed standardized, I would say, standardized way of model development, which should be made compulsory in the model development department in every banks or insurance organizations, where there will be least judgments by the model developer. Because a lot of times what happens is that model developer has to take a lot of decisions on his own, which are his own assumption, but those assumptions may not be good enough or theoretically sound enough. So it has to be standardized to the maximum extent, and that needs to be made compulsory. So model development practices should be standardized, and should be there should be a proper training on that. Model validations, and we will talk in detail about model validation in this section. Model validation is nothing but testing your model, or checking whether the model developers have done the good job or not. So model validators normally they look into the details of model development, documentation, data, data quality and all, and they point out where exactly the mistakes are in the model. And before these models are implemented, validators point this out, point this model, issues, and before these models are implemented, the issues are corrected. Then model governance, and this is a high level priority for most senior management, where senior management ensures that people who are responsible for in these activities should be governed by a committee which looks after the people, the different intellectual property in terms of the model or the documents should be well managed. And whenever there is an issue, um, um, whenever there is any requirement of any of these any of these models or documents, it should be made available. Model review. Models should be reviewed on a regular basis, because what happens is that if when you implement a model, it may not work fine after some times, and there are cases where the data might have changed after some time, and the model may not work as good as it was working before. So every model should be reviewed properly. Model monitoring. Okay. Model monitoring is like on a periodic basis. It could be weekly, monthly, or quarterly. There should be some KPI that should be, or the reports, some performance reports should be presented to the senior management, saying that the models are working fine. Every time we see some sort of an issue through these KPIs, it should be escalated to the senior management to ensure that there is no wrong information or wrong decision is taken based on the model which is being used. So that is important. All right, so we'll see the different aspects of modeling process in detail, and during this process we will learn where exactly we normally go wrong, where exactly normally people make mistakes, and that can cause model risk, or that can create issues with models, and which can be very costly for the banks. So what happens in the model development? Model development is not a routine process like any computer programs, where you write a program and you just put it somewhere in the repository, and whenever you want to run it, you just call that particular program, right? Model development, it cannot be automated. It cannot be more automated, right? Because it involves a lot of human decision making. Hence, it is prone to error making. It is prone to a lot of error, because whenever there is a judgment or a decision taken by a model developer, there is always a chance that he might have made a mistake during the model building process. Hence, there could be chances of model development. So why is it not a routine process? So when you test the data for distribution, you cannot tell for sure that this particular data follows this kind of a distribution. It cannot be automated. It has to be decided by an expert. Similarly, which particular variable is to be taken for the model, and which variables are to be left out, is something that is decided by the model developer. It cannot be automated. Hence, chances are that the developer might make mistakes while choosing variables, while choosing the kind of distribution that the data fits. So all these decisions should be well validated by experts, by expert committees, and there should be multiple people should be involved in this process to ensure that any issue with the particular developer can be captured, or can be handle in an early stage of model development. Model development involves multidisciplinary approaches, right? It involves statistics, finance, economics, accounting. So there will be people from different backgrounds. A statistic guy may not know finance. Similarly, a finance guy may not know statistics well. So it's a multidisciplinary approach, and hence there should be a teamwork while developing a model, rather than just single developer who is building a model by using theories from different academic subjects. Some of the subjects may not be his comfort area, and that's where he might make some mistake. Strict guidelines. Many places model development happen without any guidelines. That is very important. If there is no there are no guidelines in place, people will do in their own way, and which might create a lot of issues, because at a later point of time, it is very difficult to track where exactly the error has happened. So there should be strict guidelines for development. So what happens in model development? So we start with a clear statement. So problem statement should be the first thing in model development. You should understand one should understand the problem for which a model is being built, and that should be well documented, should be discussed with all the stakeholders. The people who are going to use this model, they should give a sign off on that, and then the model development should start. So the first thing to understand here is that the clear statement is there, proper statement of purpose is there. If the requirement is not clear, then there is never going to be a proper, good model. Design, logic, theory, whatever you're using should be well documented, because that's important. It's going to be used for future, and for model review and validation is going to be very useful. Whatever techniques you're using, mathematical, statistical, should be explained in detail, and its limitations should also be explained, because every statistical model or math model has some limitations. Models normally generalize things, okay, and in the process sometimes they overgeneralize, and that is a limitation of many models. So models limitations should be explained in detail, so that and in such a way that a non-technical audience can understand, so that while using it, people will consider that into account. Conceptually correct. Okay, any theory that you are using should be correct. If you are using the wrong theory, it is always going to be produce a wrong result, right? So anyone who is using a particular theory should be 100% correct about it. Alternative theories should be used to, so that you can compare the results across different theories, and then ensure that it is consistent across, because most of the times you will see there won't be drastic changes in the results that comes out from different types of models. So alternative theories should be used parallelly. Whenever you are dealing with data while building model, I'm sure most of the times you will be using data for building models, especially building statistical models. Data quality check is an important step. If the quality of data is bad, it is going to give bad output, and that has to be documented well. The sample that is taken for building models should be representative. It should represent the portfolio. If it doesn't represent a portfolio, if it misses out on certain aspects of the portfolio, it is going to give a wrong result. So good sampling techniques should be used. A proper representative sample should be taken for building a model, and there are a number of ways it can be done. Theoretically sound techniques are available, which should be used for a particular thing. And while doing this, sometimes it should be ensured that these points are being discussed with the model users, who provide a lot of good inputs or insights while selecting a correct sample. And every limitations, whether it's theory, whether it's data, whether it's the model output, should always be discussed with all the stakeholders, so that everyone is aware of it, that under what circumstances the models are not going to perform well. Model testing. Now, once the model is built, it should be tested, uh, in variety of ways to ensure it is accurate enough, to ensure that it works properly in different scenarios, and to ensure that it is going to work for a very long time and in different circumstances, so it is robust enough. Alright, so once the model is built, by the important step in model development is to use different tests, statistical tests, to check for the assumption used in the model. Every model has very lot of assumptions are there. Like for instance, if you're using a regular linear regression model, many a times you will you use the normality assumption, although it's not a compulsory thing, but for interpretation of the confidence interval, the t statistics, and so on, normality is a strict criteria for linear regression. Now, one should use a proper statistical test for that. Just by building a model is not going to work till you test all the assumptions used in the theory, and that could be multiple tests. For normality, you have so many tests, right? So one should ensure that he has to do all the tests to ensure that he's correct, because one test might fail, the other test, or maybe one test does a good, says that it's normal, but other tests say it's not normal. Then there should be a proper scrutiny. And then many times expert advices are taken into consideration while building model. But these advices do not have a reference, and these should be validated and well documented, so that at a later point of time, any issue happening with this expert advices, which do not or may not be in congruence with the the theoretical models. Any problem with that, it can be discussed at a later point. And then one thing that cannot be one cannot avoid is clear detailed documentation of the model, which is very important. And it is very important because many things that we do while building model, we forget at later point of times, whether it's writing code or taking data, or removing some of the observations, removing variables. Every single thing should be well documented. Model use. Once the model is built, it will be used for something, right? So what are the steps should be taken while ensuring that a model is used properly? It should be tested whether the model is functioning effectively. So before even you start building model, you should have some sort of an idea that the model should give some kind of a result, right? So the outcome is always there in place, and it should be matched or it should be compared with the model output. Sometimes the historical results are compared with the current result, so that's one way of doing it. Sometimes data for which is not being taken in the model development, the actual data is being used for the expected data, or the actual data is being used for the model data, and sometimes we call it as backtesting. Okay, backtesting is done. Backtesting nothing but you just take a holdout sample where that data is not being used in the model development, and then you have the actual output and the output from the model, and then you compare and see whether it's consistent or not. Model users are mostly business users, people who sit at the front side of the business, and they know how people behave in terms of the payment and all that. So they know a lot about the business, and they can provide valuable insight, and that can be very useful in the model development and model implementation cases. Reporting should be accurate. So once, there can be the cases that models are good, they're accurate, but while using the model in the report, people are making mistake. So that should be avoided. So report should be free of any issue. Any issue that is expected to come or likely to come at later stage should be discussed with the model developer well before these reports are used in production or in used by the business people. Reports should explain the confidence level and the limitations and uncertainties. Now, uncertainties with models are always there, right? So, anyone who is using this report should know that under what circumstances these models are not going to work. That should be discussed well. And then conservative approach, which means sometimes the models gives very confident outcomes, or one would be very one could be very overconfident while looking at the output from the models. For instance, when it comes to loss forecasting, let's say the model says that a particular bank is going to make $1 million of loss. Okay, so the money that a bank should hold to avoid bankruptcy is $1 million. However, a conservative approach would be like the bank should hold minimum $1.5 million as cash reserve to avoid bankruptcy. Why this 0.5? This is an additional amount that you are holding because you think that the model is actually underestimating this. So it is always good to have a conservative approach, because this is any issue with the model, which of course is known as the model risk. Any issue with this model, a bank should be in a position to survive. So it should not be very vulnerable to model risk. And that's why decision making should be conservative in nature. Alright, so the next step is, or the next important thing in model development process is the model validation. Okay, so model risk could also come from model validations. What is model validation? It's nothing but the set of processes and activities that verifies that models are performing as expected. Sometimes you will come across cases where there is no proper model validation. There are issues with the model, but the model validator were not able to find out issues while validating it or while testing the models, and that can bring model risk. So the idea is to have a process in place which ensure that all the limitation assumptions in the models should be well validated and should pass through a very stringent validation process before they go in for use, and that will be discussed in detail. So I'll stop it here, and in the next video, which is so this is the first part of the video. With the second part of the video, I'll discuss in detail about model validation, model monitoring, model governance, and model audit, and I'll see why these 4 steps are so important in managing model risk, and we'll discuss model validation and model monitoring in detail in the context of financial risk analysis. Thank you for watching this video. Please subscribe to the channel, and you can also contact me using my email ID. Thank you.